Hello, my name is Anubhav Swami, and in this video, I will talk about Cisco Secure Firewall Stateful clustering on Amazon Web Services. So without further ado, let me quickly talk about agenda for this presentation. I'll start off with quick introduction where I'll talk about what exactly Cisco Secure Firewall is and how it is managed and where you can deploy this virtual appliance in AWS. Then I'll give you a quick overview of clustering. And then we will deep dive into the architecture of clustering, where I will cover north-south use case, east-west use case, inter-VPC use case, and hybrid cloud use case. And in the end, I will share a blog where I have added a lot of information about Cisco Secure Firewall, threat defense, and clustering, and how you can deploy clustering in AWS. Now, quickly, at a very high level, Cisco Secure Firewall Threat Defense is a virtual appliance which is available in Marketplace, in AWS Marketplace. It is managed by Firepower Management Center or Cisco Secure Firepower Management Center. Firepower Management Center can be a virtual instance running in AWS, or it can be a virtual instance running anywhere on the virtual infrastructure, and it can be a physical appliance as well. It can be on-premise appliance, it can be a virtual machine running in the cloud as well. Now, coming back to the Threat Defense Firewall or Cisco Secure Firewall Threat Defense, this virtual appliance will provide you stateful firewalling capability, application visibility and control, NG-IPS, advanced malware protection, URL filtering, and you can use this appliance for VPN functionality as well, such as RA VPN or site-to-site VPN. And for the security intelligence, we get our feeds from Telos. This virtual appliance is available in AWS Marketplace. You can use BYOL, bring your own license, where you can purchase licenses, put those licenses in your smart account and consume those licenses as and when required. Or you can go with pay-as-you-go model as well. Now, at a very high level, clustering is grouping multiple virtual devices as a single logical unit. In a cluster, we can go up to 16 nodes, and we also have a special link that uses VXLAN, and this link is known as Cluster Control Link, and it is also known as CCL for short. Using CCL, we forward any asymmetric traffic, we share state, and we share other information that is required for clustering as well. Now, in the middle, you can see there is a Cisco Secure Firewall Threat Defense cluster, which is displayed as a single logical unit. And on the left-hand side, we have client, and on the right-hand side, we have our server. This cluster can grow up to 16 nodes. The other advantage of having cluster in your infrastructure is in the event of failure, we can quickly recover your connection because we share state across different nodes in our cluster. And one of the biggest pain points when you deploy firewalls in the cloud is when you deploy multiple firewalls in the cloud is introduction of SourceNAT. SourceNAT is not scalable, and there are other complexities involved with SourceNAT, where you have to, first of all, it is not scalable. There is configuration complexity related to it, and most of our customers are not interested in using SourceNAT. So in this architecture, what we do is we avoid adding SourceNAT into the configuration. So when your firewall cluster will receive packet, one of the nodes that receives the packet first time will become the owner of the connection. Director is responsible for looking up for any kind of request coming from the forwarder, so that it can look up the session owner and forward your traffic back to the scene to the owner if there is any asymmetric traffic. In this example, what you can see is SYN is received on node 1. It is processed and forwarded to the server. Now, on the way back, server responds, and since we are not using our default route in the route table, it can land on any other node as well. So if that happens, what we generally do is we go ahead and use a CCL link to forward that asymmetric traffic to the owner, and that's how we make sure that if there is any asymmetric traffic, we send it to the correct firewall, and in the event of failure, we have a backup owner that will recover your session as well. Now let's look at the traffic flow as well. In this architecture, what we have is on the right hand side, we have appliance VPC, or you can call it security VPC as well, where you have your gateway load balancer doing Geneve with a firewall cluster. You have node 1, node 2, and node 3 in firewall cluster. And then on the right hand side, we have spoke VPC. Inside of our spoke VPC, there is an instance, and requirement is to inspect all our inbound traffic. So in order to enable such kind of configuration, what we do is we apply a route table on our internet gateway. Now we will forward any traffic going to my application subnet, which is 10.81.100.0/24. We will forward it to gateway load balancer endpoint. Now, as soon as gateway load balancer endpoint will receive the traffic, gateway load balancer will forward it to gateway load balancer. Now, gateway load balancer will do hashing and forward that traffic to one of the nodes available in the cluster, and gateway load balancer will also keep track of these firewalls using health checks. So you can enable health checks, and based on health checks, if your firewall health check is healthy, your traffic is forwarded to that particular appliance. Now, once the firewall receives the traffic, we inspect it, and if traffic is allowed, we will use the same interface, send it back to the gateway load balancer. Gateway load balancer will then send it back to GWLB endpoint, and from GWLB endpoint, it will be sent to the endpoint or the workload that user is trying to reach. Now, let's take a failure event, failure scenario where the traffic was initially processed by node 2, and for some reason node 2 dies. So in that particular event, there is a new functionality on the AWS load balancer known as target failover for existing flows. And you can enable that functionality by going to your load balancer and enable rebalance functionality on your load balancer. Once you enable that functionality, your load balancer will not block any traffic for which the endpoint is not healthy. So in the event of failure, as soon as node 2 is known as a failed device or the target is unhealthy, quickly load balancer is going to rehash any flows going towards node 2 to a new instance or to the new target. This is how we receive traffic on node 3. And remember, in the previous slides, I talked about cluster control link, and I talked about backup owner. I talked about owner. So we share state across the cluster, and in the event of failure, if node 2 is not reachable, if we receive any connection which was earlier a part of node 2, we will process that on node 3 as well, since we share state across the cluster. This is really a cool feature for mission critical applications. And if you have mission critical applications where keeping state of the connection is really important, you can definitely go ahead and provision your infrastructure in such a way that you have your stateful clustering enabled in AWS. Now let's look at the other traffic flow where you have two subnets, a subnet 1 and subnet 2 sitting in the same VPC, and you want to forward traffic to your cluster. Again, you will have your route tables pointing towards the gateway load balancer. Gateway load balancer will then forward traffic to the instances will send traffic to gateway load balancer endpoint based on the routes given in the endpoints, and then traffic is received on gateway load balancer. Gateway load balancer will then send it to firewall, and again firewall will process it, send it back to GWLB. GWLB will send it back to GWLB endpoint, and that's how your end machine is going to receive the traffic. Again, in the event of failure, GWLB is going to rebalance rebalance the traffic to another target in the cluster, and that's how we ensure that your traffic is stateful and you don't see any outage in the event of failure. Now, there is another example where you have multiple VPCs and you want to place and you want to protect your inter-VPC traffic using a firewall cluster. You can do that easily by introducing transit gateway in the architecture. Transit gateway can connect to your VPCs using VPC attachment, and once your transit gateway is connected to your spoke VPCs, you can connect it to your appliance VPC or security VPC, and then based on the routes in the route table, you can forward traffic to gateway load balancer endpoint, and endpoint will then receive traffic and then again forward it to gateway load balancer, and gateway load balancer will forward it to nodes, to different nodes, to our cluster or the targets in the backend pool. Now, in the event of failure, again, load balancer is going to rebalance this traffic, forward it to another node in the cluster. Really simple. You just need to enable clustering, and then load balancer is going to quickly rehash that information and send it to another node in the event of failure. There is another important traffic flow where you have your data center connected to your cloud environment, which is a hybrid cloud model. And in this example, what we have is the transit gateway sitting in the middle, connected to spoke VPCs using VPC attachment, and your data center can be connected using VPC attachment or direct connect. In most of the cases, we have seen direct connect because that's how customer prefer connecting their data center back to their AWS infrastructure. So in both cases, what you can do is you can just control your traffic based on using route tables, and based on your route table, your traffic is forwarded to your gateway load balancer endpoints, and endpoints will then forward it to gateway load balancer, and then gateway load balancer will forward it to one of the nodes available in the cluster. And in the event of failure, again, gateway load balancer is going to rebalance that information and send it back to to another node, and that has the state already because we are using that CCL link or cluster control link for sharing state. So at a very high level, if you deploy clustering in the cloud, it will ensure that your traffic is stateful. Even in the event of failure, you will not lose your existing connection. And now I'm going to switch over to a blog, which is a new blog that I wrote on cisco.com. I will add link to this blog in the description of this video. I have added information about how traffic is forwarded to another node, what kind of functionality you have to enable on the load balancer. I've added link to our configuration guide, link to the AWS target failover for existing flow configuration guide as well. Feel free to look at this blog and go to AWS blog as well, just to understand how exactly this solution is stitched together. I hope you enjoyed this video, and thank you for watching.